All right, these notes are for environmental science. This is for graphing. As you watch and listen, you are going to add information from this video to the graphing resource sheet. So you have a graphing resource sheet. This is what the front looks like. The back side is blank. We are going to add information to the front side, and we are going to write some stuff on the back. So you'll need to do both. We are starting on the front side. Graphing resource sheet. This is going to be important because in class you're going to be making some graphs, and you need to make sure that you make them correctly, otherwise you'll have points taken off. Graphs are an important tool in maintaining and analyzing data collected in biomedical sciences. Graphs provide an important visual that allow a scientist or healthcare professional to spot trends in data and predict data that is not measured on the graph. So obviously this is a worksheet that I use for the biomed program, but it also applies to environmental science and any time that you're making a graph. Use the following guidelines to help you organize and assemble a basic line graph. So most of these instructions are talking about a line graph. There are times in environmental science that we'll do a bar graph, and I'll give you some information that we'll add to the back of the sheet that will help you with bar graphs. However, the X and Y axis, that is the same whether you're doing a line graph or a bar graph. The independent variable, the value controlled by the experimenter, is graphed on the x-axis. Independent variable on the x-axis. Go ahead and add an x down here to help you remember that the side that's laying down, the horizontal line, that is our x-axis. Dependent variable, the value that changes with the independent variable, is graphed on the y-axis. So the vertical axis, the one that goes up and down, is your dependent variable. So you might want to scooch it in there underneath, but I just put it on top here. So this is my y-axis and this is my x-axis. Add those to your graphing resource sheet. Next, we're going to be going back and forth between the front and the back of the worksheet. So we're starting down here where we're determining the scale of the graph. So determine an appropriate scale that fits the range of values. Spread the graph to fit the page and make sure that it is easy to read. Notice that I put a number 1 next to it. So draw a number 1 because then that's going to reference to what we're putting on the back. When we determine an appropriate scale that fits the range of values, that just means the numbers need to include your data. So whatever counting pattern you choose, it has to be the same all the way up the y-axis, all the way across the x-axis, and we need to make sure our data is included. Spread the graph to fit the page and make sure it's easy to read. You do not necessarily have to use a whole piece of graph paper, but we do want to make it big enough that it's easy to read. However, we need to do some planning so that we have enough room to fit in our numbering and fit in our labels. All right, so I have a number 1 over here. Turn over to the back side of your worksheet, and at the very top, go ahead and put a number 1 and then add this information. The numbering pattern must be consistent. The numbering must include all data. So it doesn't matter if you want to count by 1s or count by 2s or count by 5s. Whatever numbering pattern you choose, number it the same way all the way up or all the way across the x-axis. All right, so back on the front, and now we're at this part right here. Number and label each axis. Choose a label that clearly describes the data to be graphed. So you have to make sure that your labels are telling us, explaining what information that you have, or the labels are explaining what do those numbers mean. So put a number 2 next to this one. Then we're turning back to the back of the worksheet. We have number 1 all the way at the top. We're going to put number 2 right underneath it. So we've already done number 1. So this is number 2. So just sketch a little graph. We're just sketching a little graph. And we're kind of giving all of the things that a good graph needs. So title, the effect of fertilizer. We need to know what the graph is about. On our graph, we have a bar that shows before fertilizer is added, after fertilizer is added. So these labels right here explain the bars. But then I have a label down at the bottom of the x-axis that tells me what we're talking about. So before and after, we're talking about the tomato plant before we added fertilizer, the tomato plant after we added fertilizer. Choose a consistent numbering pattern that goes all the way up. So I'm counting by ones. So if I start counting by ones, I have to count by ones all the way up. If my data doesn't fit, or if my numbering does not fit, then I have to erase that and count by twos, or erase that and count by fives. You got to do a little bit of planning. We need a label for the y-axis as well. So what do these numbers mean? These numbers are measurements of height, and our measurements must always have units. What am I measuring the height in? Measurements must have units because that makes a difference. If I'm measuring height in millimeters or centimeters or meters or kilometers, that's a huge difference as to what these numbers mean. Okay, now I'm back on the front. So remember, this was talking about a line graph. Plot the data points with dots. The graph that we just showed, we used bars, so use bars to show your data if you're doing a bar graph. Draw the graph. If you're doing a line graph, you need to determine whether a trend can be established by connecting individual points or by drawing a curve or line of best fit that fits the data points. So when we talk about data in environmental science, we'll talk about which type of line that we need to add to our graph. But go ahead and put a number 3 here. And then we're going to turn to the back. And then we're going to sketch 2 little graphs. So this graph, we are actually connecting the data points. But this graph, especially make sure you sketch, this is a line of best fit. When I draw a line of best fit, notice that I'm not connecting these points in my line. I am just drawing a line that goes as best as possible through the middle of those points. I try to have as many points above the line as I have below the line to the best of my ability. So when you draw a line of best fit, you're not connecting them like we did over here. You're just drawing a line right through the middle of the data. Provide a key if necessary. So if we have a graph that includes more than one set of data, or multiple lines or multiple bars, you need to provide a key to identify what each line means, what each bar means. And definitely need to have a title to your graph. So notice I circled it, I've got arrows, stars. Your title should describe the relationship displayed in the graph. It's kind of like a title of the book, but it doesn't have to be super complicated. It could just be like the graph that we had right here, the effect of fertilizer. Or it could be a versus, height versus time, or mass over time, or something like that. Just talk about what the different variables are on each axis of the graph. One last thing I want you to add to the bottom of the back side is go ahead and sketch another bar graph. We don't need all of the details because on this one I just want to point out that when you draw a bar graph, the bars need to be the same width. They need to be the same size. We don't want one skinny bar and then a big old fat bar and then another skinny bar and then a medium-sized bar. The bars need to be the same size. Use the grid on the graph. That will help you. Don't try to sketch it on a graph paper. Just use the grids and follow the grid lines. That way you can make your bars the same size. We need to have the same amount of space in between bars on a bar graph. So if I have 2 spaces between these bars, I need to have 2 spaces between those bars and 2 spaces between the next and 2 spaces. I can't have 1 and then 4 and then 3. It needs to be the same amount of space. So these are the things that will have points taken off. If the bars are not the same size, there'll be points taken off. If there's not the same amount of space between the bars, then there'll be points taken off. Depending on the line, if there's not a line on your graph, whether it connects the points or a line of best fit, as the instructions tell you, there'll be points taken off. If you don't have a title, there will be points taken off. If your numbering is not consistent, if your numbering doesn't include all of the data, if your numbering is not on the grid lines as it should be, or in between the grid lines, if it's not equal, then points will be taken off. You need to have a label for the y-axis and the x-axis. If you don't have those labels, then points will be taken off. If you're doing measurements, you have to have the units. If you don't have the units on there, points will be taken off. And then we need to know, if it's a bar graph, we need to know what each bar represents. So a key or just a label underneath here is fine to give the information that you need. If you don't have that, points will be taken off. If you ever have questions, you can email me or remind me. Do a remind message. All right, so now you are going to tape in your graphing resource sheet into your environmental science notebook.
Your graphing resource sheet will go in the back of your environmental science spiral notebook. Turn all the way to the back. Open up so that you're at the very back sheet. Lay the graphing resource sheet sideways. 2 pieces of tape at the top. 2 pieces of tape on the top on the opposite side. And fold it in, and then make sure that you don't cover up the heading on it so that you know that's what you've got.